Good afternoon, students. Today we are talking about section 7.3, area of composite figures. First, let's look at this word composite. For our work today, for our definition, we're going to look at the word composite as combining together two or more shapes. We're putting together two or more shapes. And when we put things together, typically we're just adding them. We're going to add two or more shapes together. So our question is, how do I find the area of a figure that is not just a simple circle or a simple polygon? So in this example, we happen to have the letter E. It's a nice block letter E, and I want to figure out what is the area of the blue section. I started off with what I believe to be a fairly easy question, because it's dealing just with rectangles. So what I'm going to do here first is draw a line, and I think the battery is going dead on this, so I may have to grab a new one. But I'm going to draw a line, and it's going to divide the separate sections that I have here. You may choose to make your rectangles differently, but this is the way that I chose to divide mine today. As I look at this, I see that I have a rectangle right here, and this rectangle is 12 by 70. And so to find the area of that, it's going to be length times width, or 12 times 70. Then I also have an additional, let's finish this really quick. So 12 and 70 would be 840. Then I have another one over here, which is going to be a 50 by 14. So 500, 600, 700. This is 25 by, well, it doesn't tell us. So we have to use our knowledge of what these markings mean. And that means these two are congruent. They're the same, so this would be 14. So this would be 25 times 14, and 250, 350, I believe. I'll double check that one only because it's late in the afternoon. 25 times 14 is 350, yep. And last but not least, I have this one down here. We're going to just, for today, assume that this is 50, that they forgot the mark or to represent, but it looks like it's the same and accurate there. And that this is 14, so it's going to be the same as that one, and 700. All of these are centimeters squared because it was centimeters by centimeters. And then the question is, what is that all together? Remember, you have to find it all together. So, and that would be mathematically adding. So if I'm going to add all these together, I'm going to have 840 plus 700 plus 350 plus 700. Again, you can add it whatever way you want. That's most efficient for you. But I just went here, 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 and here. Add all those together. Let's see, 14, 15, 16, 17, 25. Check my math. Looks like it's still 25. All right, so 2,590 centimeters squared is this entire letter E. Just had to find each one. In case you were not sure, I suppose I should have written this at the beginning. To find the area of a rectangle or a square, I'm just going to take length times width. Length times width. So let's look at a figure like this. First, what I'm going to tell you is that in a figure like this, I know everyone can see the triangle here. I would not expect you to have to find this height. That would already be given to you, so I'm just going to mark it right now. Later on, we'll talk about finding all of that, but for right now, that would already be given to you. So what do I see here? First, I have to recognize what I see, so I know what I'm finding. Well, here I see a rectangle. So to find the area of this rectangle, I would have to go 8 times 5, length and width, 8 times 5, and that will give me 40 centimeters squared. That was pretty easy. Another rectangle. Now we have to think about the area of our other figures. Remember the formula to find the area to a triangle is 1/2 of the base times the height. And some people say base times height divided by 2. You'll get the same answer. And then I have this circle. Circle, we know, is pi r squared. However, this isn't a full circle. It's half a circle. So whatever I find here, I'm going to have to divide by 2 for this particular problem. Now, this isn't a a true realistic formula that we're always going to memorize. It just happens to be the case for this one here. So let's start with our triangle. Our triangle has a lot of digits happening here. Well, what is the height? How tall is my triangle? My triangle is 6.5. So area equals 1/2 times the base times the height. And the height is 6.5. So I'm going to plug it in, right there, drag it over. The base, the bottom, how big is this bottom? Well, it doesn't have a number there, so I have to look down below to this 5. And this 5 is the same distance as that, so my base is a 5. And then times 1/2. I'm going to take all of this and just put it into my calculator. If you don't have the fraction key, what else is 1/2? Yeah, 0.5. So I could take 0.5 times 5 times 6.5 in my calculator, and I would get that the area equals 16.25. So the area of this is 16.25 centimeters squared. Last but not least, we have our circle. So here's our circle. Oh, I was hoping that would go away, but it didn't. Here's our circle. And this right here goes from end to end, and we'll have to assume again, and I know I've told you in class to be very careful about making assumptions, but we'll assume that this is cutting it in half. And if it's cutting it in half, it means it goes through the center. And if it goes through the center, that means this 7 right here, that's the diameter. So now let's go back to our formula. C equals pi r squared. If the diameter is 7, I have to find the radius. Remember, radius is half of the diameter. So half of 7 is 3.5. So I know that my radius is 3.5 and that I have to square that. So in my calculator, I'm going to take 3.5 and square it. And then I'm going to take that times 3.14. And I'm going to get a total of 38.465. Now, just like past tests and past questions, you need to know what your ultimate goal is. What are you trying to find? Because if you lose sight of that, you're going to make a great big mistake. And that great big mistake would be to say that this shape right here has this for an area. Remember, it's not circumference, my goodness, area equals pi r squared. Remember, what we were doing here, we were finding the area of a circle, of a whole circle, but I don't have a whole circle here. So this answer is the area to a whole circle. So if I only want part of it, I have to divide my answer by 2. So when I take that and divide it by 2, I get 19.23, or just 19.2 centimeters. Remember what your ultimate goal is, your end goal. Now you're not done, because to find the whole shape, now I need to take each one of these and add it together. 40 centimeters from the rectangle, 16.25 from the triangle, 19.2 from the half circle, semicircle, and I'm going to add these together. I'm going to put in my zeros to hold my place values while I add. 5, 4, 15, 7. All right. So my final area of this entire figure would be 75 and 45 hundredths centimeters squared. 75.45 centimeters squared. That is another example. I'm going to skip over that one for right now. Here's an example. Find the area of the blue region. So this is a little bit different than before. I have had students who get to this problem and I'm like, oh yeah, I can do this. Because if I separate this, I've got this square right here. And if I separate it here, I have this square right here. And I have this blue rectangle. I can find the area to all of those and add it up. You absolutely can. There's nothing saying that you can't. This would be 5 by 4, because this is 3 plus 1. So this would be 20 units squared. If this is 5, and this is 5, and this whole thing is 13, Well, that must mean this is 3 units. So this would be 3 by 4, which is 12 units. And this would be 1 by 5, which is 5 units. 12, 20, and 12 is 32, plus 5 is 37. 37 units squared. But what happens if we look at that a different way? I'm going to look at it in the manner that this is one large rectangle. This one large rectangle is 13 by 4. 13 by 4, so I would take 13 times 4 and get 52. I got that by going 4 and 13. And then I cut out. I used my scissors and I cut this hole out. In order to cut out, in this case, I'm going to subtract, not add. And I'm going to subtract 5 by 3, which is 15. So that would give me 37. So that would be another way to solve this problem. You just have to think about how you want to. They're just different methods. It's not that one way is always the absolute right way. Before we end this lesson, I have a few extra minutes, and so I want to talk or just do another example with you. So let's talk about a rectangle. Let's see if it lets me draw this in time. So I have this rectangle, and inside this rectangle, I'm making some kind of plaques. And so I'm going to cut all the edges off. Or all the corners, not all the edges. Sorry, wrong word. I'm going to cut all these corners off. And so I want to know what is going to be the area of the inside of my shape at that point. So what is going to be the area of my plaque that's left over? So let's pretend that this was a distance of 15. Oh, very bad color. This is a distance of 15 from here to here. And let's pretend that this was a distance of 7 from here to here. And let's pretend that this was 1 and this was 1. And that all of these were equivalent. So that is the same as this, is the same as this, same as that. All right, so let's look at this. I want to know the inside piece here. And that means I have this whole thing and I cut these off. So this whole thing would be 15 times 7, which would be 105 units squared. So that would be this whole triangle. And then I came through and I cut all these edges off. So how much is one of these edges? Remember, this is 1, and this is a triangle. So the area of a triangle is 1/2 of the base times the height. So I'm going to trace this triangle. Then I'm going to grab it and drag it over here, and we're going to spin it. So what is the height of this? Remember, that would be this, whoops, that would be this number right here. If I spin this as well. So this, I know it's sideways now, but this would have been a 1 for the height and a 1 for the base. A 1 for the height and a 1 for the base. It's not letting me move it over now. Oh, that was kind of fun. All right, trying to get this out of the way. So now my height was 1, my base was 1, and I have to multiply that by 1/2. 1 times 1 is 1, times 1/2 is 1/2. So the area to this one little triangle is 1/2. What would the area of this one be? 1/2, 1/2, and 1/2. What's 1/2 plus 1/2? 1 whole. So these two make 1 whole, and these two make 1 whole. So altogether I have 2 wholes that I need to subtract. So I go back to my original dimensions, and I have to subtract 2. 105 minus 2 is 103 units squared, whatever that might be. All you need to do is sit back and look at each problem and divide it into different shapes that you know. Don't let any of the shapes be scary. As I look at some of the different problems that we have, I see something like this that might, oh, now my pen froze. Sorry about that. I see a problem that might intimidate some because of how it looks. But remember, if you are to separate this the way that they have it shown, you can make it a half circle and a triangle and a triangle. So just take your time and evaluate what shapes do you have And then know your formulas. Area to a triangle is 1/2 of the base times the height. Area to a rectangle is just length times width. And area to a circle is pi r squared. Good luck.